We don't want that water in there whipping around, whipping into elbows and valves and control valves and things like that. So first of all, what is a drip leg? So a drip leg is a connection off of a steam distribution line, whether it's a steam main or what we would call like a steam drop that goes down to a piece of equipment that's going to use that steam. We like to put a drip leg on there. Sometimes drip legs are referred to as dirt legs. It looks like a dirt leg in gas piping, right? So we're going to take a steam off of the distribution main, or even in that distribution main, and we're going to take a connection off the bottom to try and remove that water that's going down the steam pipe. Now, why is there water in our steam pipe? Because oftentimes, most of the time, we're distributing saturated steam. So as that steam gives up any heat, it's going to start to make a little bit of condensate. And that condensate will collect in the pipe along the bottom of the pipe, generally. As heat is going through the insulation, right? The insulation on our steam pipe is reducing the amount of heat loss, but we're still losing some heat. We have to lose some heat by definition. So as we're losing that little bit of heat, we're making a little bit of condensate. We don't want that water in there whipping around, whipping into elbows and valves and control valves and things like that, because it mechanically can damage those components. But also, if we leave condensate in our pipe, we're going to know it, because it's going to build a little lake somewhere in there, and then as flow rates go up and down, we're going to pick up that water and fling it and cause water hammer. So to prevent water hammer, then we're going to use good drip leg practices. Where do we need drip legs? We really need a drip leg. It's going to depend a little bit on the pressures and the process and the application and velocities, but rules of thumb are useful. We really need a drip leg every probably 100 feet to 300 feet. In some campus systems, they'll go a little further, but maybe they're making concessions with sloping the pipe downhill a little more to make sure that we're not accumulating that condensate. So there can be some trade-offs, but roughly every 200 feet, I think, is a good rule of thumb. We're also going to put a drip leg at every single steam takeoff or drop. Okay, so if we take steam off the top of the pipe so that it's good dry steam, and then we run it over to a control valve or to a regulator, now that drop, that is a dead leg, where when it's got steam pressure on it, as heat leaks through the insulation, it's going to form some condensate. And we still don't want that condensate going into the control valve or the regulator or the process, whatever it may be. So now where we have that takeoff point, we need to have another drip leg and another trap station. So it's not uncommon that we're in a processing facility and they're having issues with wet steam or water in their process, and they'll say something like, the first batch of the day, it's really, really wet. We have lots of water. Can you come look at it? And we go out and look at it and we say, yeah, the problem is your drop doesn't have a drip leg or doesn't have a trap on that leg. And so overnight, while your system's shut down, you're probably building up 10, 20, 40 gallons of water inside that pipe as it cools. And then you're shoving that water into your process because you don't have a way to remove it. So we need drip legs on distribution to prevent water hammer. And we need drip legs at every single takeoff to ensure that we don't send that water to the process. We also need a drip leg before any riser in the pipe. If you can imagine a steam pipe going along and then we turn it vertical, then the water is going to sit right there in that elbow until we get enough of it that it can seal that pipe and hammer. So anytime that we're going to have a vertical gain in elevation in a steam pipe, we need to put a drip leg right directly prior to that rise in elevation to make sure we don't create water hammer. This is a rule that I often see violated in facilities. And then they fight water hammer problems because they have a rise with no drip leg. So every 200 feet or so, at every takeoff, and at every riser in a steam pipe. What size should that drip leg be? The rule of thumb is, and again, it's going to kind of depend which reference book you're looking at, but just to give you an idea, we want the drip leg to be the same size as the steam pipe, up to about 6 or 8 inch. Once our steam main gets over 6 or 8 inch, then we can start to make those drip legs about half line size, but never less than that 6 or 8 inch. So if I have an 8-inch steam line and I put an 8-inch drip leg on it, great. If I have a 16-inch steam line, I can probably put an 8-inch drip leg on that and be fine. But if I go to a 24-inch steam main, a 4-inch drip leg is not going to cut it. So these aren't like necessarily hard, fast rules. They're good rules of thumb though. And that's really for two good reasons. So the first is if you can imagine a really large steam header, if I was to have about a 1/2 inch pipe taking off the bottom for condensate, well, there's two problems with that. If I have a river of condensate kind of flowing along the bottom of that pipe, that little 1/2 inch connection isn't going to catch that whole river, and I need to catch all of the water and get it out of there. So I'm not going to do a good job of separating out that moisture with a really small connection. I want a connection that covers a significant portion of the bottom side of that steam main in order to catch all that water. The second thing is, though, if I have a 1/2 inch pipe, a typical drip leg is going to be somewhere around 24 to 36 inches tall. Well, a 1/2 inch pipe, 24 to 36 inches tall, is only going to hold, a 1.5 cups of water. It's not going to hold very much water. So if I have a carryover event in the boiler and I get a slug of water into my system, I'm not going to have anywhere for that water to go. I don't have any storage in a really small pipe. So the bigger my main, the more storage I should have at those drip legs, because remember, the running trap attached to that drip leg is just kind of letting slowly out, maybe a few gallons an hour. So I need to make sure that if I get 10 gallons, I have somewhere for it to go while that trap is doing its job and slowly removing that from the system. So I need some storage capacity. So a nice big drip leg has a lot more storage capacity to handle those upsets and then to slowly bleed that back out into our condensate system. Drip legs before every riser, every 200 or 300 feet, at every takeoff. Nice big drip legs, because honestly the cost of the drip leg at installation really isn't that much. The length of the drip leg doesn't matter much. It's the same number of welds. The material's not terribly expensive in the grand scheme of things, when you're talking about the installation cost of a steam system. But the maintenance costs for not having good drip legs, for breaking things all the time, very, very high. It pays to make really generous size and length drip legs, to have good trapping practices to avoid dangerous situations in the plant, but also water hammer that can damage a lot of equipment.